Moving on to chapter 4.4, we're going to to talk about ways where we can prove that two triangles are congruent when we're only given certain pieces of information. So right now, all we know is that if we have two triangles that have 3 of the same angle measures and 3 of the same side measures, then they're congruent triangles. We're going to start to learn some shortcuts, ways that we can use to prove that two triangles are congruent without necessarily having to find 3 angle measures and 3 side measures. The first one that we're going to do is side, side, side. So this is called side, side, side because we're going to prove that each corresponding side of triangles are congruent, then they're congruent triangles. Just by having the sides, we can determine if triangles are congruent. We don't even need the angle measurements if we have all 3 sides being congruent. So, if the 3 sides of one triangle are congruent to 3 sides of a second triangle, then the two triangles are congruent. So remember, we've been talking about the difference between equal and congruent. Equal is referring to actual numbers, meaning their lengths. Congruent means they are the same. So these little tick marks are showing that AB is congruent to SR, meaning they have the same length. So AB and SR, or AB and RS, are the same. All right, so we have one side. Now we have BC, see how it has 2 tick marks, and ST. Those are congruent as well. They have the same number of tick marks. Finally, we have AC and RT. Those both have 3 tick marks, so those 2 segments are congruent. All right, how can we use this in a proof? How can we use this particular postulate in a proof? I just drew a little T so that we can write out our statements. And our conclusions. All right, what do we always start with our proofs? We always start with our given. So step 1 is that KL is congruent to NL. And in this case, I'm going to write the 2 givens in one step, just because you could do it as 2 steps as well. Sometimes I just like to throw them in one step. It might save me time. But if you do it as 2 steps, that's totally fine. This is our given. All right, so we have 2 side lengths are the same. We have that KL and NL are congruent because they both have 1 tick mark. You can see that from the picture. And then you have KM is congruent to NM, 2 tick marks in the picture. So using our side, side, side congruence postulate, we need 3 sides to prove that these triangles are congruent. We have that 2 corresponding sets of sides are congruent. Now we need the 3rd one. What's the only set that we haven't dealt with yet? Well, we've got this line right here. We have LM. The way that we would write this is just by saying LM, which is on this triangle, LM, is congruent to, well, it's the same side on the other triangle as well. So we can say that that triangle also has a side length, LM. Doesn't matter that it's the same. That's what we're looking for. So since both of them have that side length LM, we can just say that it equals itself. And what's the property that says that something equals itself? That's the reflexive property. Reflexive property. It seems silly, but we have to state it. That way we can get 1, 2, 3 sets of congruent corresponding sides. Now that we have those 3 sets of congruent corresponding sides, we can say that triangle KLM is congruent to triangle NLM because we have 3 sides. That's our side, side, side congruence postulate. Side, side, side congruence postulate. We had 3 sets of corresponding congruent sides. All right, let's determine whether or not these statements are true. This is saying it's a statement, and we have to prove whether or not it's true. DFG, so DFG, is congruent to triangle HJK, HJK. Let's make sure their tick marks line up. So if I start with D, and I'm going up to F, all right, 2 tick marks. Let's see if that matches. H, going up to J, 2 tick marks. So far, we're in the clear. Now we're going from F to G. See FG here. Now we're going to go from J to K. All right, both 3 tick marks. Finally, we're going to go from D to G. So over here, that's our first and third letter. And our first and third letter over here is H and K. All right, 1 tick mark, 1 tick mark. Looks like this statement is true. Okay, it's important to do it like that because let's say I had switched. Let's say I said that this one was 3 tick marks and this one was only 2 tick marks. Yes, you can see that maybe this has 3 equal side lengths, but you need to make sure that the actual statement is true, that they're going in the correct order. We talked about those congruent statements before. We need to make sure they're going in the right order to determine whether or not they're true. All right, let's try it this time. We have ACB, triangle ACB is congruent to triangle CAD. Let's see if it checks out. Let's start with AC, AC, and CA. 9 equals 9, they're sharing a side. So far, we're good. Now we have CB and AD. CB corresponds to AD, and it looks like they're both 7, so they're corresponding and congruent. Finally, we have AB, which is like first and third, and CD. AB is 3, CD is 4. All right, they do not have the same length. So this means that this is not true. That's false. AB was 3 and CD was 4. Those are not congruent triangles. That congruent statement is not true. All right, let's check out this one. Triangle QPT is congruent to triangle RST. Let's make sure that each corresponding part is congruent. QP corresponds to RS. So QP has 2 tick marks, RS has 2 tick marks. All right, so far we're good. Now we have PT corresponds to ST. So PT has 3 tick marks, ST has 3 tick marks. Awesome. All right, last one. Q to T corresponds with RT. So QT has 1 tick mark, RT has 1 tick mark. All right, looks like this is true. When we're looking at one like this, it's a little bit trickier because we kind of have to look at these overhangs, the overhangs from these triangles. We're going to decide whether or not they're congruent. Let's start with the easier ones. We have sides AB being 4 units, and ED is 4 units. All right, so we have 1 set of sides. We're good for 1 set. Let's check for another. We have BC is 6, and EF is 6. Okay, we have 2 pairs of congruent sides. Finally, let's look at this length. We have AC and DF. AC and DF. So if I'm looking at AC right here, we know that it's whatever this shared side length is. I'm going to call it X. CF or FC, we're just going to call it X. We don't know what it is, but we know that both sides of the triangles share it. So we can see that AC right here is equal to 2 plus X. Now we're just using X. We're not going to solve for it. We're just using it as a placeholder. We're just going to call it X. All right. Now we know that we're calling FC X, and we can also see that DF is going to be 2 plus X, that little overhang plus X. So it looks like, since x is going to be the same, it looks like AC and DF are the same length. It's just 2 plus whatever that length of FC is. You also could have just said that AC equals 2 plus FC. See right here? AC equals 2 plus the length of SC, while DF equals 2 plus the length of FC. Meaning AC is equal to DF, which means AC is congruent to DF. Looks like we have a congruent triangle. Let's write the congruent statement. I have triangle A to B is 4 units. We also have E to D. Now, to determine which one we write first, we just kind of have to start to decide a direction. So for the first one, we have A to B is 4, B to C is 6. So to replicate that on the other side, we're going to start with our 4 and then our 6. And make sure that we're going in the right direction. So we went from D to E is 4 and E to F is 6. So that means that we're going from D to E to F. The reason that it's important to do that, because I could have easily said, all right, well, ED is 4 and EF is 6, so I could have written it in the wrong order and said EDF. But that would be going from here to here, and then our sides wouldn't correspond correctly. We want to make sure that everything's in the correct spot. All right, you try the next one.